Welcome to today's lecture. So we're going to continue chapter 2. We covered 2.1, 2.2, 2.3. We're going to start 2.4 and hopefully we can finish 2.5 as well. So a little bit of review. What we learned so far, we learned that statistics is a branch of math. It includes some steps. The very first step is to ask a question. Then we start collecting the data. After we collect the data, we're interested in finding patterns in our collection. So we try to visualize the data. After visualizing the data using pie chart, bar chart, histogram, and so on, we're interested in having numerical characteristics assigned to our collection. So we try to analyze the data. After analyzing the data, we're going to make some conclusions. So far we talked about asking a question, collecting the data, different measures of data, then visualizing the data, use different charts or frequency table. Now we are on analyzing the data. Remember that to analyze the data, we're interested in finding two important measurements for our collection. We're interested in finding the center of the data, which was related to mean, mode, median. The second important characteristic for our data is the difference in data or objects or values in your collection. So, the difference. When you're talking about the difference between our data, we're interested in finding the range, or another important characteristic that involves every data in the collection is standard deviation. We talked about center, mean, mode, median, where the data are centered. Today we're going to talk about the difference between the data, especially the average difference between the data and the mean that we call standard deviation. So let us talk about the range, then we move on talking about standard deviation. Very well, we are on page 1 of the note. Let us talk about range. What is range? Definition. Very well. Range of data, range of the collection is the difference between the maximum value in your collection and the minimum value in your collection. Is the difference between the maximum value and minimum value in the collection. So as a statistician, your job is to find the maximum value, to find the minimum value, and find the range in your collection. So the formula range is equal to max minus mean. Let us go over one example to feel comfortable about the definition of range. Very well. In example 1, the question says, find the range of a data set. You have 2 corporations, each hired 10 graduates. The starting salaries for each graduate are shown. Find the range of the starting salaries for corporation A. Well, in example 1 on page 1, for corporation A, we want to find the range. So first you need to find the maximum value, then you need to find the minimum value, do the subtraction, and that's it. So the range for the first corporation, the maximum value is 47 minus the minimum value is 37. When you do the subtraction between these two, you can see the range is equal to 10. Well, it says the difference, the distance between the maximum value in your collection and the minimum value in your collection is just 10. Okay, it's not very bad. So the maximum salary, minimum salary, the difference is 10. If you think about in thousands, the difference is 10 thousandths. So here's a question for you. How about the range in corporation B? And if we compare these two ranges, if we compare these two numbers, what's the meaning of those two numbers for these two corporations? As a statistician, you should be asking, okay, what does this number tell me? Let us calculate the range for the second corporation and try to see what information we can derive from those collections. For the second corporation, the range is equal to, so let us find the maximum range. The maximum range is 58. And the minimum range is equal to, let's see, 23, okay? 23. So if you do the subtraction, the range in the salary in corporation B is equal to 35. So think about it this way. If you have just graphs of these two corporations, the minimum is 37. The maximum is 47. And the difference between these two, the range is 10. So this is for corporation A. The second corporation, which has a range of 35, has minimum range, minimum salary 23. So 23 goes here. And the maximum salary is 58. So it goes here. And the range, the difference between these two numbers is here. So what's the meaning of that? It means that the first corporation is more centered around either the mean, median, or mode, but there is difference between the data in the second corporation. So by looking at the range, as you can see, you just grab the maximum value, the minimum value, and you find difference between these two numbers. I expect you to ask, what about the rest of the numbers in the collection? How can I use those information? Okay, of course, we cannot just use range in this case. The definition of range says, hey, I have maximum value, I have minimum value, and that's it. It doesn't include any value, any number in between maximum and minimum value. So we have to move on to a new definition. In this case, first we're going to talk about deviation, deviation from the mean. Then we're going to build something that we call standard deviation in our collection. Well, let us start defining deviation. We are on page 2. So suppose mean of your collection, the mean of the population, let's for the population, is given as mu. Remember that for population, you're using Greek letters, mu representing the population mean. For each data value like X in the collection, the deviation is, so deviation of X is defined as the distance between X and the mean. X minus mean. Again, deviation means the difference between each value and the mean. I expect you to ask, what if I'm working with a sample? Note that if you have a sample, then deviation is defined. Deviation of X is equal to X minus X. Well, after finding the deviation between each value in the collection and the mean, we're going to square each of those numbers. So let me erase this part of the board. Now, we square each deviation. So for each X value, you find the difference between that X, that number in the collection, and the mean, then you square it. So you get X minus mu squared. If X is 1, 1 minus the mean squared. If X is 2, 2 minus mu squared. If X is 3, 3 minus mean squared, and so on. So that depends on your collection and how many data you have in your collection. You have to repeat this process as many times as you have data in your collection. What's next? Then we add all of these deviation squared. So after we find each of them, we add them all together. Finally, we divide the sum by n, which is the number of values in your collection. Very well. This number is called variance. In previous step, we found the variance. So what's wrong with variance? Variance is actually a number, and the unit assigned to variance is unit squared. So, for example, you're a statistician and you want to know what is the average distance, the average difference between each salary and the mean salary in corporation A. What are you going to do? You're going to find the mean. You're going to take each salary minus the mean, square it, add all of those squared together, and divide by the total number of values in your collection. So, since you squared the salary, it means that if the salary is in dollars, the unit that you get is dollars squared. It doesn't give you anything meaningful. So what we're going to do, we're going to find the square root of variance, and we call it standard deviation. Finally, we take the square root of the variance, and we call it standard deviation, SD. Very well, some important symbols for you. So, remember that for a population parameter, if you are working with the mean of the population, you denote it by mu. If you are working with standard deviation of population, the Greek letter that you're going to use is sigma. When you're working with your sample, if you have a sample, the mean of the sample is x bar, and standard deviation of sample is denoted by S. So know the difference between different symbols, because those representing characteristics for either population or your sample. If you use mu, it means that you're working with your population. When you're using sigma, it means that you're working with your population. Of course, X bar representing the sample and S also representing your sample. Well, let us go over one example to feel comfortable about this. So we are on page 3. And our goal is to find the population variance and standard deviation for corporation A. So for corporation A, find variance and standard deviation. Very well. So if you get back to example 1, you can actually see the numbers, the salaries listed for corporation A. So let us list all of these and form a small table to keep track of our calculations. So salary X, remember that X representing each value in your collection. Then we need to find the deviation between each salary and the mean. So X minus mu, X minus the mean. In the next step, we need to square each of them, X minus mu squared. And finally, add them all together and divide by the total number of values in the collection. Perfect. So the first salary, 41. The second salary, 38. Next salary, 39. Then 45, 47, 41, 44, 41, 37, and 42. Very well. So what's the mean of our collection? If you calculate the mean, mu is equal to 41.5. Before completing the second column, we need to find the mean of the collection. What we do, we add all of these together and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get the mean of our population. So this is the mean of the population. Very well. In the next step, we have to take each x. X is equal to 41 minus the mean 41.5. So 41 minus 41.5, 38 minus 41.5, then 39 minus 41.5, then 45 minus 41.5, 47 minus 41.5, 41 minus 41.5, 44 minus 41.5, 41 minus 41.5, 37 minus 41.5, and 42 minus 41.5. So what are we doing? We're finding the deviation for each x. If x is 41, the deviation is 41 minus 41.5. If x is 38, the deviation is 38 minus 41.5. Remember that you have to do the subtraction for each x value. This is your x, This is your x, next x, and the rest of them. Okay, let me erase this and leave a little bit of space. Okay, the first deviation is negative 0.5. The second deviation, negative 3.5. So this is negative 0.5. The next deviation is equal to negative 2.5. The next deviation is equal to 3.5. Now it is positive. Next deviation is equal to 5.5. Next deviation, negative 0.5. Then here you have 2.5. Next deviation, negative 0.5. Next deviation, negative 4.5. Next deviation is equal to positive 0.5. So we calculated each of these deviations. In the next step, you have to square each of these numbers. Very well. Our next step is to take each of these numbers and square them. Okay, so it means that you are multiplying negative 0.5 by itself. So here you have negative 0.5 squared. You have negative 3.5 squared. You have negative 2.5 squared. You have 3.5 squared. You have 5.5 squared. You have negative 0.5 squared. You have 2.5 squared. You have negative 0.5 squared. Negative 4.5 squared and 0.5 squared. Very well. In this case, you have 0.25. Then you have 12.25. Then we get 6.25. And now you have 12.25. And let's see, next number is going to be 30.25. Next number is going to be 0.25 and 6.25, 0.25. And let's see here, we get 20.25 and finally 0.25. Note that all of these numbers are positive because we square negative value, it's going to be a positive number. So these numbers are important. Why is that? Because we're going to take each of these, add them all together, divide by 10, which is the total number of values in the collection. So now we're going to add all of these. Add them all and divide by the total number of values in your collection. In the corporation A. And we call it variance. So your variance is equal to 88.5 divided by 10. So your variance, the symbol that you're using for your variance is sigma squared, which is equals to 8.85. This number is unit squared. So whatever the unit is, In this case, you have dollars. So it says the average distance between each salary and the mean salary is $8.85 squared. It doesn't make sense. What should I do with dollars squared? It doesn't give me anything meaningful. So I'm going to find the standard deviation. Standard deviation, which is square root of your variance, which is square root of 8.85. So my standard deviation is equal to 3, almost $3. So remember that we said these salaries are in thousand. Standard deviation is 3,000. So what's the meaning of that? It means that on average, the distance, the difference between each salary and the mean salary in corporation A is $3,000. Well, there are different websites that you can use to find standard deviation for a collection. So during solving the homework questions, checking the answers, I encourage you to use those websites, online websites, to find standard deviation. So let us get back to our website. So one of them is called Alcula. You can Google Alcula standard deviation. The first link gives you Alcula. Very well. So here you can enter the data that you have. So the salary that we had was 41, 38, 39, 45, 41, 44. So after 45, I have 47. Let me correct that. 45, 47, 41, 44, 41, 37, and 42. Okay. Let us submit the data. Note that since we are working with population, we selected population. If you use sample, you see a difference between these two values. So let us submit the data. Very well. As you can see, the population size is 10, mean is 41.5, and standard deviation or sigma is 2.97. If you round it up, you get 3, which is 3,000. Let's get back to our note. Very well. So take a look at these symbols on the left-hand side. When you're working with population, the variance is denoted by sigma squared. So you put a little exponent, which in this case 2, on top of sigma, and you have your variance. Remember that variance gives you unit squared. For sample, we're using S squared. Standard deviation, which is variance, square root of the variance, is denoted by sigma for population. For sample, its square root of variance, which is S. We talked about mean of the population before. It's denoted by Greek letter mu. And for sample mean, we're using X bar. Population, the size of the population or the number of entries for your population is denoted by capital N, and for your sample is denoted by small n. Well, when it comes to deviation, the deviation in population is denoted by X minus mu, the difference between each X value, each entry, and the mean. For sample, however, it's denoted by X minus X bar. And finally, we have sum of squares. This symbol here is also called sigma, capital sigma, which is, the meaning of that is addition, sum. So we find each deviation, X minus mean, we square it, and we add all of those numbers together. Let's go over another example. We're finding the sample standard deviation and variance. So the operation is the same. All the steps are the same. The main difference is using n minus 1 on the denominator, so the size of your sample minus 1, and the symbol that you're using is not Greek symbols. Since you are working with sample, the symbols are different from population. So variance of your sample is S squared and standard deviation of your sample is S. So let us get back to Alcula, enter all of these numbers to find our sample standard deviation. So I'm going to just paste these numbers here. They put comma, comma, to separate these numbers. And since I'm working with a sample, my question says you have a sample. It's not a population. So I'm going to click on sample, select sample. Let us submit the data. Well, the sample size is 12. Mean X bar is 7.5 and standard deviation or S is 1.88. If you round it up, you get 2. Let us take a look at our solution using the table. As you can see, standard deviation is 1.9. If you round it up, you get 2. Well, as a statistician, you have different collections. You have a lot of different numbers, and it doesn't make sense to use paper and pencil and write down everything, find the deviation, square it, add them all together, and divide by the total number of entries in your collection. So eventually, you're going to use softwares. For example, in page 5, you're going to see office rental rates listed here. Statisticians using Minitab, Excel, or in some cases they use TI-84 or 83 to calculate the mean, standard deviation, variance, and other characteristics for the collection. So let us collect this data. copy and paste them in Alcula. Let us separate these all. Okay, one more row. Okay, perfect. Let us submit the data. Sample size 24. Mean of your sample is 30.96. As you can see, the standard deviation, or S, is 12 point, you can round it up, 12.6. Using softwares, online calculators, they are very fast, they are very accurate,